Dear First Prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new lesson. The lesson today, inshallah, is the second lesson in the Congruent. It's Geometry Unit 4, Lesson 3. Last time we took Unit 4, Lesson 2. The lesson was the congruent of the shapes, line segments, angles, and polygons. Today, inshallah, we are going to learn the congruent of triangle. Why triangle? Because the triangle is a special case of the polygons, and of course it has some special properties. Let's start the lesson. The triangles, as we see, if we have this triangle and this triangle, okay, if they are congruent, then that means the corresponding elements are equal in everything. And for example, the corresponding sides are equal in length and the corresponding angles are equal in measure. But first we need to learn what's the meaning of elements of the polygon. ABC is congruent to XYZ. The elements of the triangle formed from 6 elements. Any triangle formed from 6 elements. The elements are the sides and the angles. For example, ABC, okay, and XYZ. AB congruent to XY, this is the first element, this side and this is a side. BC congruent to YZ. CA congruent to XZ, okay. The three elements here called the sides, the three sides, okay. Then the three sides of triangle ABC and the three sides of triangle XYZ are congruent to each other, okay. Now I mentioned three elements, okay. Next, the fourth element, angle A with angle X. The fifth element, angle B with angle Y. The sixth element, angle C with angle Z. Then this called the angles. Then what's the meaning of the elements of the triangle? The elements of the triangle means the sides and the angle. The angles. That means the triangle contains how many elements? It contains 6 elements. Again, it contains 6 elements. Okay. Now, if we have two triangles ABC and XYZ like this, and we need to prove that they are congruent, I think it's very, very difficult case to prove that the two triangles are congruent, because to prove that the two triangles are congruent, you need to have the three sides and the three angles as a given, and this is a very difficult case and this is impossible, okay. But we can prove that two triangles are congruent if we have only three elements from both triangles, okay. Of course we have the three elements, okay. I can't select the three elements randomly, okay. I can select them by using 4 special cases. Let's learn the first one. The first case with us is called SAS, or side angle side. Okay, if we have ABC triangle and XYZ triangle, okay, ABC and XYZ are congruent if what? If 3 elements from the first triangle and 3 elements from the second triangle are congruent, but according to this case, SAS, side angle side. For example, here we have AB congruent to XY. AB congruent to XY. AB is a side and XY is a side. Okay. Number 2, BC congruent to YZ. BC side congruent to YZ side. Okay. Number 3, angle B congruent to angle Y. Again, angle B congruent to angle Y. Notice here that angle B is included between the given sides. Okay, the given sides AB and BC angle B included between them, and angle Y included between the given sides. So we say that it's SAS, two sides and included angle. Then the two triangles are congruent like this. We say that two triangles are congruent if two sides and included angles in the first in one of them are congruent to their corresponding elements in the other triangle. Okay? Someone asked me question, Mister, if we have angle Z and angle C are equal, angle B and angle Y are not equal, then the triangle here are not congruent because the given angle C and Z are not included. They must be included. Okay? Okay. Now, if the two triangles are congruent, then what will happen? Okay? Here we have some results like this. Since the two triangles are congruent, then AC and XZ will be equal. Angle A and angle X will be equal. Angle C and angle Z will be equal. And this is called the results of the congruency. Okay, now we have learned the first case, which is SAS. Remember with me the first case. Okay, now I'm going to teach you the second case. I said before there are four cases. Okay, the second case with us is the opposite of this case. Okay, this case is SAS. The second case is A.S.A. Here we have two triangles. The case called A.S.A. Angle side angle. ABC triangle, XYZ triangle. They are congruent if, let's see the three givens. Number one, angle C must equal angle Z, for example يعني. Number two, BC equal to YZ. Number three, angle B congruent to angle Y. Here we have angle B and angle B and angle Y. They are angle B and angle Y. Okay, BC connect between them. Angle Z and angle Y. I'm sorry, angle B and C. B and C, two angles, and BC here connect between them, and Y and Z are two angles, YZ connect between them. Then we can say that two angles and side between them. Here, two angles and side connect between them. The case here is A.S.A. Okay, two angles are congruent if two angles, two triangles are congruent if two angles and included side in the first triangle are congruent to their corresponding elements in the other triangle. This is the case, must be two sides and included angle. The results of the congruency will be like this. The first result, AC is equal to XZ, AC equal to XZ. Number two, AB is equal to XY. Finally, angle A equal to angle X. And this is the case, the second case. The third case with us is called SSS. SSS means side, side, side. Let we have ABC triangle and XYZ triangle. Okay, the two triangles are congruent if, number one, if AB side congruent to XY side. Number two, BC side congruent to YZ side. Number three, CA side congruent to XZ side, like this. In that case, we can say that two triangles are congruent if each side in the first triangle is congruent to its corresponding element in the other triangle. Here we have three sides in the first and three sides in the second, then they are congruent according to the case which is called SSS. The results of the congruent will be like this. Angle A will equal angle to X, will equal to angle X. Angle B will equal to angle Y. Finally, angle C will equal to angle Z. Now we are going to learn to the the fourth case, which is called the case of the right angled triangle. It's called R.H.S. Okay, now we have two right angled triangles like this. Okay, the side here which is opposite to the right angle called hypotenuse, and the side here which is opposite to the right angle also called hypotenuse. The two other sides called sides of a right angle, and here also right sides of a right angle. Okay, the case called R.H.S. R.H.S means right hypotenuse and side. Again, right hypotenuse and side. Okay, let's study the case. ABC triangle, XYZ triangle. They are congruent if number one, if AC equal or congruent to XZ, يعني the hypotenuse are congruent. Number two, BC congruent to YZ, that means side BC and the side YZ are congruent. 3. Angle B congruent to angle Y. Again, angle B congruent to angle Y. This is the right angle. Then, again, hypotenuse congruent to hypotenuse, side congruent to side, right angle congruent to right angle. So it's called RHS. Then we can say that two right-angled triangles are congruent if the hypotenuse and the side in the first triangle are congruent to their corresponding elements or parts in the other triangle. And the result in that case will be like this. AB will equal to XY because they are congruent triangles. Angle A congruent to angle X because they are congruent triangle. Angle C congruent to angle Z because they are congruent triangles. Remember with me, we have four cases. The four cases are SAS, second A.S.E, third SSS, fourth R.H.S. Let's solve some problems about it. Example 1. In each of the following figures, show if the two triangles are congruent or not. Okay, if they are congruent, name the case. The case here that I am going to write SAS or SSS or A.S.A and so on. If they are not congruent, give reason, given that the similar signs denote the congruence of shown elements labeled by this sign. That means star and star equal angles, dash and dash equal sides, double dash and double dash equal sides. Okay, let's study the first case with us. Here we have, in this triangle, we have AB congruent to DE, and this is a side, and DF congruent to AC, this is another side, and the angle included between the two sides here is A, and the angle included between the two sides here is D, and the two included angles are congruent. Then the two triangles here are congruent. Okay, then I can say that triangle A B C is congruent to triangle DEF because number 1, number 2, and number 3. Number 1, AB side is congruent to DE side. Okay, number 2, measure of angle A uh, equal to measure of angle D. But if I need to write the symbol congruent, then I'm going to cancel M from here and here to be angle A congruent to angle D like this. Okay. You can write equal and you can write congruent. It's up to you. Okay. Finally, D AC side congruent to DF side. Okay. The case here is side angle and side is S.A.S. Okay, now I can write the results. Number one, we are going to see that BC equal to EF congruent to EF. This is a result number one. Result number two, angle B congruent to angle E. Finally, number three, angle F congruent to angle C. This is number two. Okay, this was the results and the reasons and the results. Okay, the next one, here we have DC included dash and AB included dash, then they are equal sides. BC side equal to AD side, and AC here is called the common side. Here, and if they have a common side, this represented a third side. Okay, here we have the two triangles are congruent because the side AD and side BC are equal. This S, DC, and AB, this is another S, and AC is the third S. Then is a common side, the third S. Then we have SSS. Okay, then I can say that triangle ABC is congruent to triangle DCA because number one, AD congruent to BC. Number two, DC congruent to AB. Number three, AC is a common side. Okay, and the case here is SSS. Okay, let's solve the next one. I will not write the results here. I don't need it. Okay, here we have AO and DO have dash its side, and OC and OB double dash its another side. Angle O, which is DOC, equal to angle AOB, its angle. Angle O here included between the two sides, and the angle O here included between the two sides, then the case here represent SAS, then the two triangles of course are congruent. Okay, then we can say that triangle AOB, AOB, AOB like DOC, congruent to triangle DOC, because number one, DO congruent to AO. Number two, angle DOC congruent to angle AOB. Number three, OC congruent to OB. And the case here is, as we see, SAS. Okay, the next one. Here we have BD and DC have one dash, they are equal. Angle BDA and angle CDA have the same sign, they are equal. And AD is a common side. Okay, we have two sides and the included angle here, two sides and the included angle here, then the two triangles are congruent. Then I can say that triangle BDA is congruent to triangle CDA because number one, BD congruent to CD. Number two, AD is a common side. Number three, measure of angle BDA equal, here I'm sorry, I will write angle BDA is congruent to angle CDA. The case here, as we see two sides and the included angle, it's SAS. Okay, let's solve the next one. Here we have angle A equal to angle F. Angle C equal to angle C, it's VOA. BC equal to CF, but BC is not included between the two given angles A and C. Okay, then this one is not one of the cases. Okay, because we have here two angles and side is not included, then they are not congruent because it's not one of the previous cases. Okay, we can write this one by many different reasons. First, I'm going to say that triangle A B C not congruent to triangle ABC FCD because the included sides are not congruent. Or you can say that AC not congruent to FC. Okay, the next one we have here AD is congruent to the C. Oh, and those are right-angled triangles, side equal to side, and right angle equal to right angle. And here the hypotenuse is common. We have here common hypotenuse. Then the two triangles are congruent because hypotenuse is common, right angles, side and side, it's R.H.S. Okay, then triangle ABD is congruent to triangle CBD because number one, AD is congruent to CD. Number two, BD is a common side. Number three, angle A is congruent to angle C, and they are right angles. This case is R.H.S. The next one, number 7. Here we have angle C equal to angle A, double curve. Angle C equal to angle A, one curve. And the AC is a common side. Here we have two angles and the side included or connected between their vertices. And down we have two angles and side connected between their vertices. Then the two triangles here are congruent and the case is A.S.A. Then triangle ABC is congruent to triangle CDA because number one, angle BAC congruent to angle DCA. Number two, angle CAD is congruent to angle ACB. Number three, AC is a common side. Okay, in that case, the case is A.S.A. Okay, let's solve the next one. Here we have example 2. In the opposite figure as we see here, AB is equal to AD. Okay, it's side. BC equal 7 centimeters. Angle BAC and angle DAC both equal 25, and the AC is a common side. Then the two triangles are congruent. It's SAS. Why it's ASAS? Sorry, AB equal to AD side, AC common side. The included angles are equal. Okay. Then triangle ACB congruent what? Let's follow the direction A C B. It's congruent to A C D. Yes, to triangle A C D. And measure of angle D. Angle D here exactly like angle B, it's equal 30 degrees. Okay, CD equal what centimeters? CD like CB equals 7 centimeters. Measure of angle ACD, ACD exactly like measure of angle ACB. We have triangle. The triangle, the sum equal 180. Then it's equal 180 degrees minus open brackets 25 plus 30 equals 125 degrees. Then we have here 125 and here 125. Okay, don't forget the sum of angles of triangle equal 180 because we need this rule many times in this example. Okay, sorry, in this lesson. Example 3. Here we have AD bisects, and we explained meaning of bisect. Bisects mean divide into equal halves. AC bisects angle DCB and DAB. Okay, that means that angle DAC equal to angle BAC, and also that means angle DCA equal to measure of angle BCA. Okay, and here we have a common side in between. Then the two triangles are congruent, and this is ASA. ASA. Okay, as I explained many times. Here we have ADC triangle congruent to what? ADC exactly as ABC. Again, ADC exactly as ABC. ABC. Okay. Measure of angle B. Angle B like angle D equal 100 100 degrees. BC here equal to what? Equal to CD equals 6 centimeters. I think it's very easy, very easy. The next one here in example 4, in the opposite figure, C is a midpoint of BD midpoint. That means BC equal to CD. That clear in the figure. And AC perpendicular to BD. That means here we have right angle and here also we have right angle. Okay, that clear that the two triangles are congruent. Why? Because we have side equal to side and we have a common side in between. Okay, and the right angle equal to right angle. It's SAS. It's SAS. Okay, this is a common side. Okay, side angle side. Okay, AB equal 5 centimeters and measure of angle B equal 57 centimeters. Find the length of AD. To find the length of AD, first we need to prove that the two triangles are congruent, because he didn't mention this one. Okay, then I will say that triangle ABC is congruent to triangle ADC because number one, as we learned before, AC is a common side. Number 2, measure of angle, angle ACB is congruent to angle ACD. Number 3, BC is congruent to CD. Okay, and the case here is R.H.S. Then we can say that AD equal to AB equal 5 centimeters, comma, and measure of angle DAC, to measure angle DAC. Here we have a right angle here 90, and here we have 90 here. This angle 57, then this angle also 57 degrees. The third angle here, okay, will equal measure of angle DAC equal 180 minus open brackets 90 degrees plus 57 degrees. It's equal to 33 degrees. Okay, let's solve example 5. Example 5, here in the opposite figure we have BE bisects angle ADC. Okay, then ADC, then this angle equal to this angle, and ABC, then this angle equal to this angle. Okay, from that, angle BDC supplement angle CDE, and angle BDA supplements angle ADE. Then we can say that angle BCD equal to angle BDA. Okay, now we have angle, the two angles here are equal and the two angles here are equal, and the side connect between them is common. Then the two triangles are congruent, they are A S A. Okay, now we can prove that the two triangles are congruent like this. Triangle A B D is congruent to triangle ABD is congruent to triangle CBD, because number 1, angle ABD is congruent to angle CBD. Number 2, angle ADB is congruent to angle CDB. Number 3, BD is a common side. And this is exactly two sides and the included angle, it will be A.S.A. Okay, now we need what? We need to find the length of BC. BC here equal to BA, then BC equal to BA equals 8 centimeters, and the length of AD exactly as CD, then AD equals CD equals 6 centimeters. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.